Hey guys, and welcome to this video. So this is my first video on the channel. I am going to be running a series on Kubernetes. I have about 2 years of industry background in Kubernetes. It's an interesting technology that I'm continuing to learn, and I wanted to broadcast my understanding of Kubernetes to a wider kind of audience, put it out there on the internet. So this video will be a very basic, high-level overview of Kubernetes, what it aims to achieve, some of the very basic concepts, and in the future I'll be looking to dive into more complex topics or look at things in a lot more depth. So let's just jump into it straight away. So this is my Kubernetes introduction. So an overview, what is Kubernetes? Kubernetes is a container orchestration platform. What that means is essentially it gives us a whole array of functionality to deploy containers to whatever environment that we want to deploy them to. So it automates the provisioning and replacement of containerized applications. And what that essentially means is that if we want to deploy a certain application using a container, we can specify in a YAML file what we want to deploy, and Kubernetes will determine where in our cluster, in our say set of machines that are allocated to Kubernetes, that it should be deployed. And let's say the container goes down at some point, Kubernetes will look after re-provisioning that container. So it gives us a great deal of availability. So next point is actually right around that, and that is that Kubernetes is designed with scalability and availability in mind. So as we go through the topics, you'll see that Kubernetes at each layer provides the ability to scale in and scale out, and this in turn allows us to have a highly available system because we can deploy Kubernetes across various machines. So we could be running the same workload or the same application, let's say, on different machines. So if a single machine goes down, we still have availability within that application because there are containers running the same workload on a different machine. Another thing to understand with Kubernetes is that it constantly runs in a control loop. So what does that mean? You can think of an example like a thermostat in your house. So you set what you want the temperature to be. So let's say you want it to be 25 degrees in your house. You set that parameter. The thermostat monitors the current temperature, and then based on whether it's too warm or too cold, it will either trigger the heating or not trigger the heating. So Kubernetes works the same way. If you say you want 3 containers of a particular application deployed, Kubernetes will ensure that at all times you have 3 containers of a particular application deployed. So it takes away a lot of the manual toil with regards to ensuring that particular applications are in the state that you want them to be in. Containers. So you can think of containers as a standard unit of software. They consist of a binary and the dependencies that are needed to run that binary. We can also think about containers in relation to VMs. A lot of people come from a background of VMs and then they transition to containers and they're like, oh, what's the difference? Well, think about the difference essentially as VMs have an operating system, containers do not. So what that means is that there is an abstraction layer with containers that is higher up the chain. So with VMs, our virtualization takes place at the hardware level. With containers, the virtualization takes place at the operating system level. So as I mentioned, a container is just an application and its dependencies. with virtual machines, you might have an application, its dependencies, and an operating system. So that's the difference. Pods. Pods are a group of one or more containers with shared storage and network resources. Nodes are essentially either physical or virtual machines on which pods can be deployed. Each node is managed by the control plane and contains the services necessary to run pods. So that's just a quick overview of nodes. We'll get into details on a later video. The control plane is essentially the brain of the Kubernetes cluster. When we talk about the control loop, the control plane is what orchestrates the entire control loop, from monitoring the current state, storing the desired state, and remediating any variation between the desired and the current state. So how does it do that? There are a few key components that I will quickly go through. It stores the desired state using etc.d, which is a highly available key value store. It decides which nodes to run pods on using the scheduler. It manages cluster state, e.g. responding to when nodes go down using the controller manager. So the controller manager is actually a bundle of different controllers. One of those controllers is the node controller. So the example that I gave, if a node goes down, the controller manager will detect that and it will add a new node to the cluster. So the control plane also gives us an interface to interact with the Kubernetes system, and this is called the API server. So what the API server does is it exposes an API. Quite simple. So if you want to deploy a new workload, you will specify that using a YAML file and send it to the API server. The API server will then store that in etc.d, and then the scheduler will say, okay, what resources do we have in this cluster? Depending on where there is space, which nodes have space in the cluster, it will deploy the workload to a specific node that it knows it has space. And then once the pod or whatever object is up and running, the controller manager or a specific controller will look after ensuring that the pod remains up. Clusters. So we've already kind of mentioned what a cluster is, but a cluster is essentially a number of nodes, including the control plane, where the control plane can be deployed across any of the nodes, but generally we have dedicated nodes for the control plane, and those are called master nodes, and they consist of all of the components that I have mentioned in the prior slide. Okay, so that is the first video. I hope that was a little bit useful for some people who viewed it. If you have any feedback, please let me know, and please like and subscribe to the channel if you don't mind.